Welcome back. In the last class, we have seen the characteristics of enhancement mode NMOS transistor along with its working and operation. That means we have discussed the three conditions in the NMOS enhancement mode transistor. The first condition is whenever VGS is less than 0, it is a cutoff region. Whenever VGS is greater than 0 and VDS is less than VGS minus VT, it is an active region. And whenever VGS is greater than VT and VDS is greater than or equals to VGS minus VT, it is a saturation region. Now the point is we have to discuss about depletion mode NMOS transistor. If you observe that what happens in depletion mode NMOS transistor. In the depletion mode NMOS transistor, okay, even though there is no potential between gate and source, that means if you short a gate and source potential, let us assume it is connected to ground, even though there is no potential, there is a channel in the depletion mode transistor, right? Why? Because in the depletion mode NMOS transistor, while fabricating, there is a extra fabrication step which is known as ion implantation. Therefore, the channel is already there even though there is no potential between gate and source. That means VGS is equals to 0. Here, based on this, it is an important point. We have to assume that according to this condition, VGS should be greater than, sorry, it is not greater than 0, it is greater than threshold voltage. Sorry for that. Okay, whenever VGS is greater than threshold voltage, then only we are having either a active region or either a saturation region. In the both the condition, if you want, you may observe. Here the point is when VGS is equals to 0, okay, then according to this condition or this condition, the VGS should be greater than what? Threshold voltage. Now, if VGS itself it is a 0 volts, then how we are going to tell that it is greater than threshold voltage? Anybody from this? Yeah, absolutely. That means the threshold voltage you have to assume that it is what? A negative threshold voltage. Is it clear? If the threshold voltage is negative, then you can very clearly say that 0 is greater than the negative voltage. In this manner, the condition will observe in the depletion mode NMOS transistor. Is it all of you? Is it understood all of you? Okay. Now we will see the characteristics of NMOS enhancement mode and a depletion mode transistor. Now we are going to observe the characteristics of enhancement mode NMOS transistor and depletion mode NMOS transistor. Okay, while observing the enhancement mode and depletion mode NMOS transistor, if you are having any queries, you can please comment. And after completion of this NMOS enhancement mode and depletion mode transistor characteristics, don't forget we are having an enhancement mode PMOS and enhancement mode, sorry, depletion mode PMOS. Okay, exactly opposite to NMOS transistor. Therefore it is a task to you guys to perform the vice versa operation of enhancement mode NMOS and depletion mode NMOS to achieve enhancement mode PMOS and depletion mode PMOS. Okay. Now we are going to observe the characteristics of enhancement mode NMOS transistor. Before that, I am once again recalling the conditions. The gate to source voltage must be greater than threshold voltage, and whenever VDS is less than the effective gate voltage, the current is going to be increases. That means active region. When VDS is greater than or equals to VGS minus VT, the current is going to be stay constant. That is saturation region. Now let us assume that the threshold voltage of this MOS transistor is 1 volt. That means definitely if you want to have a channel, the gate to source voltage must be greater than the threshold voltage. Therefore let us assume that the gate to source voltage is equals to here, okay, 2 volts. Is it clear? Now observe very carefully. Now I am taking the scale here, 1 2 3 4 5 6 and so on. Now observe very carefully. When gate to source voltage is 2 volts, now what is the effective gate voltage? VGS minus VT. That means 2 minus 1. Okay, 2 minus 1, which is equals to what? 1. That means whenever VDS is less than this 1 volt, the current is going to be increases. Therefore I will show with some other color. The current is going to be increased up to 1 volt. From thereafter it will be in constant. Is it understood? That means this is the point where this is the voltage from where the current is going to be, okay, constant. Now let us take one more gate to source voltage. Let us assume that the gate to source voltage now is 3 volts. I hope that are you clear. Now tell me that 3 minus 1 becomes what? 2 volts. Absolutely. Therefore, up to 2 volts, if you observe that from up to 2 volts, yeah, absolutely. From there onwards, the current is going to be constant. Is it clear, all of you? Okay, now tell me yourself. We will take one more gate to source voltage. Yeah, if you want, you may take 4 volts. What happened? 4 minus 1 is equals to what? 3 volts. Therefore, the current will increase up to where? 3 volts. Now, if you observe the characteristics, okay, the current is going to be increase up to this voltage. Why? Because according to the condition, VDS should be less than VGS minus VT. Therefore, up to this, the current is going to be increased. From there onwards, it will stay constant. I hope that are you clear. In this fashion, you can talk about the characteristics of NMOS enhancement mode transistor. Is it clear? That means the region where the dots are available. Okay, this region you may call this one. If you observe very carefully, this one. Okay, from this one you may call this is what? Active region, and this is what? Saturation region. Is it understood, all of you? Okay, now this is the NMOS enhancement mode characteristics. We will look the depletion mode NMOS characteristic. Don't forget, while you are talking about enhancement mode PMOS transistor characteristics, the entire thing should be in the negative side. I hope that are you clear, all of you. Okay, now we will see the depletion mode NMOS characteristics. Now, if you observe the depletion mode NMOS characteristic, don't forget in the depletion mode NMOS, the gate to source voltage is 0. Now, we know that what is the threshold voltage of depletion mode NMOS transistor? Negative. Therefore, let us assume the threshold voltage is what? Negative threshold voltage. Now, let us take the condition when VGS is equals to 0. If you observe that when VGS is equals to 0 volts, now let's take the scale 1, 2, 3, 4, 5 and 6 and so on. Now what is the effective gate voltage? Absolutely the same condition you have to follow. What is the effective gate voltage? VGS minus VT is the effective gate voltage. Now if you observe that 0 minus of minus 1, which is what? Plus 1. Is it clear? That means up to 1, if you observe that from up to 1 voltage, when VDS is less than 1 voltage, then you are having the characteristics. Is it clear, all of you? Therefore, I will draw some more clearly, guys. Okay, why? Because I have to show the next also. Therefore, this is up to 1 voltage, then it is your characteristics. I hope that are you clear. If you further increase the gate to source voltage, what will happen? Just understood yourself. If VGS is plus 1 volt, now observe that this is 1 minus of minus 1. What is that? 2 volts. Absolutely. That means if you observe that in the next condition, it will be 2 volts and it will be like this. Is it clear? These are the point where the current is going to be constant. Is it clear? If you further increase, what is happening? If you observe that, now observe yourself, 2 minus of minus 1. What is that? 2 minus of minus 1? 3 volts. Absolutely. That means up to here, if you observe, up to 3 volts, current is going to be increased. From there onwards it is constant. Now the question here is, okay, if you are increasing the positive potential, the current is going to be increased. What happens if you decrease the potential? Now let's take minus 0.5, as your VGS. Now observe very carefully. Now here if you observe that here it is minus 0.5 minus of minus 1, which is equals to what? 0.5. That means up to this point, up to 0.5, let us take this one. Okay, the current is going to be like this. Now that means if you observe that the current decreases when gate to source voltage is negative potential. Is it understood? Now if you further observe that if VGS is minus 1 volt, what will happen? If VGS is minus 1, therefore minus of minus 1, that is VT, which is equals to what? 0. That means up to here point itself you are not having any current. Is it understood? That means in depletion mode transistor, if it is 0 volts, there is a current. Okay, if it is positive potential, the current is increasing. Okay, if it is a negative potential, the current starts to decreasing, but up to where? That means up to whenever VGS equals to VT, the current is there. Whenever VGS equals to VT, from there onwards, you do not have any current. Is it understood, all of you? This is regarding about the characteristics of NMOS enhancement mode and depletion mode NMOS transistor. Now it is a task to you guys to perform the characteristics of enhancement mode and depletion mode PMOS. Don't forget, exactly opposite to NMOS transistor. If you are having any doubts, please comment. Is it understood? Okay, thank you very much. Have a nice day.